Welcome to lecture series on design and analysis of algorithm. In today's lecture series, we are going to discuss about algorithmic approach called as brute force approach, and under brute force approach, we are going to see about selections sort algorithm. So let us have a quick recall on what are the topics we have seen earlier to have better understanding on selection sort. So we got to understand about the need for algorithm analysis. We have seen time complexity and how to perform mathematical analysis on non-recursive algorithm. We have seen what is brute force approach, which is the default algorithmic approach that any problem can be solved with. And under brute force approach, earlier we have seen bubble sort algorithm. So today we will see about selection sort algorithm. So these are the topics that we are going to discuss today. We are going to see how does this selection sort algorithm works, and we will see the analysis of selection sort algorithm. We will also discuss about its advantages and disadvantages. So now look at this real world problem. We have several use cases to discuss, like teaching in computer science is one use case, embedded system is another use case, preparing for an interview is another use case, and working on low light environment is another use case. So every day we come across more than one use cases, and in order to solve all these use cases, what is the best algorithm do you think can be applied for? This is what we are going to discuss today. So one such algorithm that can be applied to solve these use cases is selection sort algorithm. And this algorithm starts sorting the values from the last, from the end. So the maximum value is always moved to the end in case of selection sort algorithm. So this is the working of selection sort algorithm. Initially, it compares the first element with all the other elements of the list and find the smallest element. That particular smallest element will be swapped with the element at the last, and it continues until the list is sorted. So now look at the first step. Uh, the value at the zeroth index or the first element is 89. And of the remaining values, what is the minimum one? It is 17. So this minimum value is swapped with the value in the first index. So 17 is brought to the front and 89 is moved to the position of 17, which means the value at the first is sorted. Now, uh, you move to the next index. Now the second, second index has the first value, right? So the value that is present in the second, actually in the first index is 45. Now of the remaining values, what is minimum? 29. So 29 and 45 are swapped together. Similarly, the next value is 68. Of the remaining values, 45 is, sorry, of the remaining values, 34 is minimum. So those two are swapped together. And next one is 90. And of the remaining values, 45 is minimum. So 45 and 90 are swapped together. And again, we have 90, and of the remaining value, 68 is a minimum, and these two are swapped. And again, at the last, 90 is swapped with value 89. So this is the working of selection sort algorithm. So it requires n squared by 2 comparisons. So on the average case, the worst case time complexity of selection sort algorithm is order of n squared. So here, this represents the number of comparisons required. And the advantages of selection sort algorithm is it is very simple to understand and it is easy to implement for beginners. It is also called as in-place sorting algorithm, which is it does not require any additional array to perform sorting, or it does not require any extra memory to perform sorting. So that is why it is called as in-place sorting algorithm and requires n minus 1 swaps in each step. So it works well when the data set is smaller, and it is also suitable when the number of elements are smaller. So these are some of the drawbacks of selection sort algorithm. It has very poor time complexity. That is, its best average and worst case time complexity is order of n square. It is not suitable for larger data sets. So the algorithm slows down when the input size increases, and it is not a stable sorting algorithm. Unlike the other stable sorting algorithm that we have seen, example is bubble sort. It is less efficient than other sorting algorithms like merge sort, quick sort, and insertion sort. because its relative order may change. So its relative order of elements, equal elements may change. So here is an assessment. Now consider an array containing values 64, 25, 12, 21, and 11. Now we have to perform selection sort on this array of list. So how many passes do you think is required? So in the first pass, 64 is swapped with 11, and in the next pass, 25 will be swapped with 12, and again in the next pass, 25 and 22 are swapped together, after which no swapping is required. So you will get the sorted list in 3 passes. So similarly, you apply selection sort algorithm for the remaining examples given, and you can trace the algorithm to have better understanding. So for each example, you see how many comparisons are made and how many number of passes are required. So let us summarize the topic we have seen so far. Uh, so the core mechanism behind the selection sort algorithm is the brute force approach, and its average best and worst case time complexity is the order of n square. It is best suited for smaller data sets, and its key characteristics, it is simple, and it is an in-place sorting algorithm. Minimum number of swaps are required, so it enhances memory efficiency when the data set is smaller. So these are some of the references of selection sort algorithm. Hope you understood the topic. So in the next lecture, we will discuss some other interesting topic on DA. Thanks for watching.